All right, today we're going to review a little bit of what we've done the past few days on finding the line of best fit. This is set 59, and here we talked a little bit about creating a scatter plot with real-life data, which is called experimental data. So we went ahead and we plotted. We had fluorine on our x-axis and nitrogen on our y-axis, and we plotted those points in a scatter plot. And because that slope goes up from left to right and all these points are close together, that's called a positive correlation. Now here we went through these steps here at the bottom, and the first thing we did is we drew a line through our data, just the average of our data. So all of us will have a different equation of our lines because we have different lines that we drew. It's just an average. So once we draw our line, we pick 2 points on the line, good points like here and here, and wrote those down as an ordered pair. Once we wrote those down, the first thing we needed to find was the slope. So we went here and we found the slope, which you can see the formula at the bottom, change in y over change in x. Okay, once we found our slope, we chose one of the 2 ordered pairs. In this case, I chose 32, 200. And we took those points and put them in for x and y into our slope-intercept form. And here is our slope. Once we did that, we'll go ahead and solve for b, which is our y-intercept. And we found that b goes through our y-intercept at negative 1,800. So we then put our slope and our y-intercept back into our slope-intercept form to find our equation. Now, because we're talking about real-life data, in place of the y, we put an N for nitrogen. And in place of the x, we put an F for fluorine, which shows that it's the real-life data that we're talking about, rather than just x and y. So what we're going to do now is we're going to use Geometer's Sketchpad to find the equation of a line of best fit. And there is a link for a student worksheet on the class website that you can also look at. So let me bring that up. We'll bring up the Sketchpad here. And I have already plotted the points on this graph. And you can see down here at the bottom, this is the foot length, and over here is the height. And this data is data that was used for an archaeologist who found a shoe and wanted to maybe estimate the height of the person that shoe belonged to. So that's what this data is. So we have foot length and height. So the point, you'll plot your points on your Geometry Sketchpad, and then we're going to draw a line. So we'll click on our line, and we'll come over here and just draw a line just through the average of your data. There's no right or wrong. It just kind of is the average of where your data is. Now, once you do that, be sure you go back to the arrow and click out of that, so you don't have to continue to draw lines. Now we're going to measure the equation of that line. So we'll click on it and go up to Measure and Equation. And that will give us, up here as you can see, the equation of that line. A lot easier than having to do it by hand. So from there, we'll go ahead and what I want to do is called residuals. So we come down here and this is a custom tool, and we go to residual. And what the residual does is it will measure from this point to your line. So you drag it to your line, and you do that with all the points. You highlight the point and you drag it to the line. Highlight the point, drag it to the line, and you just do that with all. Now if your point falls on the line, you really can't measure it. There's not a distance from it to the line. Whoops, let me undo that. Just like that, if you make an error, just edit undo. All right, so I'm back at A. I'm going to highlight A, go to the line, and it will measure that. Measure to the line. There we go. Now, what the residuals measure is how far the point is off your line. Okay, how far are these points away from your line? That's what a residual tells you. Now, on the top, you notice that they're blue, and on the bottom, you notice that they're red. Okay. So from there, we're going to go ahead and measure the distance on each of these, and that will tell you then the total distance those points are away from your line. Okay. So to measure those, you want to go ahead and go up to number, and we're going to calculate. And all you have to do is highlight this and then add them. It's very simple. Highlight, add, and just this calculator will add it for you, so you don't even have to do that yourself. Thank goodness for technology. Okay. Keep going. We'll get all of these highlighted, and then we'll just find a grand total when we're done, and that number will show up on the screen. And we'll just kind of see how far. Okay, it looks like better do B here also. All right, okay. So the total distance is 91.33 units from the line. Okay, and that's how far off your lines are, or your points are from your line. So that's your residual. Now, what we want to do is we want to maybe move that line, which is nice that you can do with this. You want to adjust the line so we can make this 91.33 as minimum, as small as possible. That will just be the best average for our line, the smaller we can make it. So you can grab your line and you can move it. Notice how my number is moving there. So it looks to me like the smallest number is about 80, somewhere in the 80s. So we'll just keep moving it around till I can get it in somewhere in that vicinity. I thought I saw an 80. All right, that's pretty close to an 82. So we want to get the minimum number that we can. All right, so let's see, let me just, okay, looks like right now the best I can do is maybe 82.88, and that's fine. So then we're going to come off and get off the highlight so it's not highlighted. And now we're going to find the equation of this line. Okay, and we'll just kind of see the difference. So this is the line of best fit really, because it minimizes all those distances from the points. So we'll highlight it again, the line, and then we'll measure the equation. This then is the new equation that we have. Oh my gosh, look at that, it's the same. Let me try that again, because usually that shouldn't be the same. Unless we did pretty good on our first line, I guess. Maybe that would be, let's see if we can just move that a little bit more and get a little bit smaller. If not, it looks like we got it pretty darn close to the best that we could. Okay, minimize. All right. So look how much you can move that line. All right, so without wasting too much time, we'll just go as small as we can here. So I'll just leave that. We'll just go with that 83. Go up a little bit. Okay. All right, we'll just leave it there. Let me just try and remeasure that line again. So we'll highlight it. And again, we'll measure. And we'll measure the equation and just see what we end up with. Okay, so we're getting the same equation on our kale that we did up here. So it looks like we did a pretty good job with getting the minimum line. So what you want to do now is we want to take that real life data, which is what we found right here. Okay, now remember our y-axis stands for our height and the x stands for our foot length. So we're going to pick a point. So you want to go over here to the point and put a point anywhere on that line, anywhere on the line. There we go. And I'm going to take that point, and what I want you to do is I want you to move that point on the line. Okay, so that point's on there. Let me be sure and get out of the points here with the arrow. Okay, now take this point that you just did and move it up and down the line. Okay, so you can see how that point will move. Now you want to go ahead and highlight your point, and you want to measure, measure coordinates. And that is the coordinate of that line. Now let's go ahead and try and move this until, what I want to know is if your shoe size is a size 19, approximately how high will that individual be? So we take this point, and notice this is the ordered pair right there, and watch how it moves when we move the point like we did earlier. So let's get that to about 19, as close as we can get to 19. All right, and so there's 19, we're pretty close there. There we go. Let's just stop right there. That's pretty close. So what we have found is a person who has an approximate foot length of 19 centimeters will be approximately 147.63 centimeters tall. So that's using a line of best fit, using experimental data in a real-life situation, which is what our lesson is reviewing on GeoSketchpad. So open up your the class website, go to Algebra 2, and find the link on there and click on that, and you'll have a student worksheet on here, and you can do this yourself and try and come up with the same data and answer the questions on the worksheet. And have a great day.